Question 5. Diagram shows a wedge, all of whose faces are smooth. Smooth means no friction, thank God. Resting on a smooth horizontal table. Smooth horizontal table, good. Its faces make an angle A and B with the table. We're tan A. So right away, I'm just going to work out my triangle here. Okay, so we already know that sine A, cos A, they are going to be over 5. Okay, opposite over adjacent, so 4 over 5 and 3 over 5. And then we're going to note that tan B is 3 over 4. Cos B, adjacent is the bigger one this time. Oh, sorry, I'll do it this way. Sine B is 3 over 5. And cos B, 4 over 5. Okay, so just get that done out of the way to start. And then just leave it up there for later on. Now, particles of each of mass m, so we both know that these are mass m. Mass m, mass m. Are placed on the face of the wedges. If the mass of the wedge is 2m, show that the wedge will not move. Okay, so we have to prove that the wedge here has no acceleration. Basically, A equals 0. You got it? So A is going to equal 0. Okie dokes. So let's begin. We're going to start off. I drew a fairly big diagram here because I'm going to need it. Weight goes directly down. Then I resolve perpendicular and parallel. Now, this reaction force here, there's always going to be a reaction force. Call this one R. Call the reaction force on this one S. Okay? Anybody tell me this angle in here? A. Now just stop for 1 second. Okay, now we're going to do the same thing again. Except this time we're going to do it over here. Weight goes directly down. Yeah. Construct a line perpendicular to it, and then construct a line parallel to it. What you've done there is you've drawn your two white triangles. Remember that we always do the white triangles. Okay. Now we're both told they're of mass m, and the wedge itself is 2m. Okay. So what we have here is mg. So I'll just do this quickly. Mg cos A, mg sin A, mg. Anybody? This one here. Sin B, and then mg cos B. Okay. Now this is where this comes in handy, where you just get these guys here, you just bring them down, or you have them in the top right of your page. Now we're just going to go around and fill them all in. Mg cos A, 3 over 5 mg. Okay, so 3 over 5 mg, no bother. Next one, 4 over 5 mg. This one here is the opposite way around, 3 over 5 mg. And then the other one, 4 over 5 mg. Okay, that diagram there can serve as my what's that word? It can serve as my 2 separate diagrams for the particles. Okay. Now, next thing we're going to do is we're going to call this acceleration F. We're going to call this one here acceleration B. 2 different accelerations for the 2 different particles. And then we're going to have acceleration A for the wedge as a whole. What's the goal of the question again, guys? A equals 0. Alright, so we have to figure out that. Okay. Now, what we're going to do, while I have this in a visual range, what I'm going to do is I'm going to do the equation for the 2 of these, but I haven't done my What have I not done yet? Acceleration triangles. Now, how many acceleration triangles am I going to have? Now let's picture this, right? Let's picture what we did last time. What we did last time was F is in a weird direction. A is going directly across the grid. We have to translate A into F's language. So what we do is we pretend there's a big line for A. We bring it down here. That's A. Everybody agreed? Then what we do next is that we draw up our angle, because that's parallel to F, and then we finish off our triangle at roughly 90 degrees. Let's do that a bit better. So 90 degrees would be there, right? So that's pretty accurate now, and I'll just fix that up, right? So there's one acceleration triangle. I'm going to move that down bit by bit, like so. And there it is, an acceleration triangle with angle A, and then this here is 90 degrees. Now, let's get this. This is going to be A cos A, and that's going to be A sin A. Everybody agrees with that? Same technique as last time. Otherwise known as 3 over 5A and 4 over 5A. So 3 over 5A and 4 over 5A. Everybody cool with that? Now, we have to do another one. Because B, see this acceleration B? Acceleration B is in a completely different direction to acceleration F. Therefore, we have to translate A into a direction that B can understand. Okay? So we come along again, choose a different colour this time, we'll go for red. Okay, and we just draw the triangle here. So once again, I'm translating that A is an acceleration going this direction here, bring it down to the bottom of the wedge, then up like this, and then down, and all of a sudden what we have here is your triangle is complete. Drag all the pieces down individually, and now you have angle B this direction here, your second triangle in this regard. Is that okay? Now, what is this side here? That's 90 degrees. Oh, sorry, that side there is actually A. The hypotenuse is always A. So what about this part here? Yeah, it's going to be A sine B, and as you rightly said, 3 over 5A sine B. It's the opposite side. See, it's in the opposite direction to the last triangle, because angle A was in the bottom left, but for this acceleration triangle, it's on the bottom right. So it's A sine B, which is 3 over 5 A. And then the other one here, cos 4 over 5A. So it turns out, same triangle, but coincidence, not by design, okay? So, where the link up comes in here is that you have A, which is this direction here. A going straight across, so that's diagonally right up, diagonally right down. A going straight across, so diagonally right up, diagonally right down. Now, with all this information at hand, we now got to go about doing our very first equation. This is all prep work. We haven't even gone into doing the actual equations yet. Okay, so let's start off with the one on the left, the mg, so the mass particle on the left. Okay, F equals ma. Let's do it going diagonally left down. Any ideas how to go about doing this? Somebody start me off. What's driving it down? 4 over 5 mg. Cool. Anything sending it back up the plane? Pulling at it, opposing its motion? Nothing. Okay, what's ma then? This here? Oh yeah. Now m by f, but this time it has something opposing it, which is going to be 3 over 5. Yes, you're right, 3 over 5a. So everyone understand how we got that? He looked at his acceleration triangle. He picked the direction that's parallel to the equation we're working on, and it's going against the acceleration because the acceleration f is going downwards, not upwards, downwards. Okay? So that's the first one done, okay? Let's do the next one. Multiply both sides by 5. Remember to multiply in the m. 4mg equals 5mf minus 3ma. Good with that? Now, let's try the next one. I'll just box this off for a minute. Send it down here, out of the way. Still want to be able to use my diagrams. Okay, next one. We're going to do f equals ma, but this time it's in the down direction. It's perpendicular to the f, so going straight down. Now, what's the f value that's sending it downwards in that direction? 3 over 5 mg. So 3 over 5 mg sending it directly down. We're talking about this green triangle here. The r value working against it. 3 over 5g minus r. Okay, and then what does that equal? The only acceleration going directly down is the 4 over 5a going directly downwards. Okay, once again multiply both sides by 5. 3mg minus 5r equals 4ma. Label it equation 1, equation 2. Draw a line down the middle. Okay, so we have 2 equations out of 5. Go again. Same procedure. Okay, so we're looking up. We've exploited the green triangle to the best of our ability. This information is now exhausted. We got our 2 equations from it. Moving on. We're next centering in on this section here, and we're going to get another 2 equations from this section here. Okay, so let's begin. Okay, start off in which direction, guys? Which direction is B going in? F equals, so bottom right, once again, MA in this direction here. Okay, let's start off. What force is dragging B down that hill? The 3 over 5 mg dragging it directly down. Or directly to the right. Okay, anything opposing its motion? No, leave it alone. What about its acceleration? M times? Here's the catch. Okay, B is going bottom right. B. Now you usually take away because it's going in the opposite direction, but we can see that in this case here, the wedge's acceleration is actually complementing its current direction. So in a case like this, it's plus 4 over 5 a. That's where they get you. Okay? So, that's where they get you, lads. Now, what we're going to do here is multiply both sides by 5. So 3mg equals 5mb and plus 4a. One mistake every time. 4ma. Okay? And then 3. Equation 3. Now, once again, box it off. Okay, box it off, bring it down, and now we're going to have to do the next one. So, What direction does the next one go in, guys? The next one? Huh? So the direction of the next one is, we've done parallel to B. Now we're going to do perpendicular to B. So this direction here. Go again. What's forcing the this particle here down in that direction? 4/5 mg is forcing it directly down. What is opposing that motion? Not R this time, S. Both of them have different reaction forces, okay? So minus S. Now, equals MA. M times what's A this time? Anybody? A is going to be just it's going to be 3/5. Give me a second. This one here, guys, we usually expect the A value to be positive because we're expecting it to aim diagonally left down. But in this case, it's aiming diagonal right up, which means that's a minus 3/4, 3/5 A. Whoever called that, good job. Alright? Multiply both sides by 5. 4mg minus S equals minus 3ma. There's another equation there. Remember in the previous... 5s, you're right. The 5 and the S are looking very similar, so I'm instantly regretting using S. So this here is 5s, 5, and I'm going to make the S quite small, 5s. Okay? So we have all 4 equations ready to go. So what we can just do here next is we can see all 4 equations. Now, what we haven't done any work on whatsoever is the wedge as a whole. Okay? So all this work I did here, every single last bit of it, we're just going to move it down out of the way, and we're just going to be saving it for later, so to speak. So, give me 1 second. There we go. Bye bye. Now that's moved down the way. Now we're just back looking at this one here. Okay. Now, because I've already used this stuff here, I can afford to get rid of it. Okay. So what I can do is just get rid of a lot of this garbage here. Wasn't garbage. Now it's garbage. Okay. So this is it. Ignore the weights. Okay. Now what we're going to have is we said that the R and S are still important though. So this was R going in this direction here, right? So now it's going to be R going in this direction here because it's from the wedge's perspective. Okay, so that's R going in that direction there. So what we have is R coming in this way here, and then we're going to have S coming in this direction here, and we're going to have another reaction force N. So from the wedge's experience, it feels a weight on its left side, it feels weight on its right side via the reaction forces, and it also experiences being supported from the ground underneath. So it experiences 3 different forces. Its acceleration, as discussed before, is A. Can anybody tell me what to do with R and S? What do we always do with the reaction forces? We break them down in directions that's understood by the acceleration. The acceleration goes directly to the right, which means that I'll only understand directly to the right or directly up and down. Okay? So, this here is angle A, this here, angle B. This means this is R cos A, this is R sin A, this is S sin B, and then S cos B. Okay? Now we're just going to remove these things here, and I'm just going to fill them in properly. So, r cos A, anybody? 3 over 5, or going directly down. The next one, 4 over 5, or going directly to the right. Next one, S is going to be 3 over 5, S. I'm going to name that R1 and R2 from now on, okay? What about the other one? 4 over 5, S. Is that right? Now, we got to do an equation for the overall motion of the wedge. Very simply put, F equals ma. What direction is the wedge going in? What direction did I say the wedge is going in? To the right. Okay? So the wedge is meant to be going directly to the right. Okay? So, therefore, what are the forces driving it right and left? Let's start with forces to the right. 4 over 5 R. Anything else to the right? Anything to the left? 3 over 5. I'm going to try and make that really small. S. Then it should equal. What's the mass of your wedge? 2m. And then its acceleration? A. That's it done. That's your wedge equation, otherwise known as equation 5. Now, we got to take a long look at the information we need. We have to prove that A equals, anybody? 0. Okay, now I want you to have, we're going to pay really close attention to this, okay? Now, what we have a problem is at the moment is that are R and S compatible? R and S aren't compatible. Is there a choice of an equation with R and S? Well, we can find out what 5R is using equation 1, and we can find out what S is using equation 4. Have we see that? Yeah? So, what we're going to do here, guys, is we're going to use equation 1 and equation 4. So, what we have here is we're going to use 3mg, so 4ma. Sorry, move the 4s over the other side and move the 4ma over the left. So we're going to get 5r equals 3mg minus 4ma, and then we're going to divide by 5. R equals 3mg minus 4ma all over 5. Is everybody happy with that? Now, the next one after that is we've got to figure out what S is on its own. What is S on its own? It's over here, so bring the 5s to the left and the 3ma to the right. So we're going to get 4mg plus 3ma, and that's going to be equal to 5s divided by 5, 4mg plus 3ma, so say all over 5, all over 5 equals S. These two equations here are going to end up being in here and here. Alright, let's see what happens. So, 4 over 5 multiply by 3mg minus 4ma all over 5 minus 3 over 5 multiplied by 4mg plus 3ma all over 5 equals 2ma. Now let's just be really patient with this, okay? 2ma. So they're all going to be over 25s, aren't they? So look what happens here. Oh dear. So So what's 4 over 5 25 on the bottom anyway, right? We'll just do it this way. 25 on the bottom, divided by the 5, 4 by the 3, 12 mg, 4 by the minus 4, minus 16 ma, minus something over 25. So it's going to be minus, brackets, I'll just use brackets here, 12 mg plus 9 ma. Is it 9 ma? Plus plus 9 ma at the moment. I'm going to put this over 25 as well. If I had to multiply top and bottom by 25, and that'll be 50 ma, all over 25. 25s can all go. Next we're going to have 12 mg minus 12 mg. So 25s take a hike. So we're going to have 12 mg take away 12 mg. They're going to cancel. We're next going to have minus 16 ma minus 9 ma is minus 25 ma equals 50 ma. And then just bring it over to your side and we get 0 equals 25 ma. A equals 0. I'm about to say one of the most important things I can say about this full chapter, okay? We did a lot of extra work that we didn't actually use. How in a test do you identify the work you don't have to do and speed up your full question is what we have to figure out here, okay? So look at this. Let's go back to the very beginning. And we're saying is, show that the wedge will not move. Questions where you're only concerned with the acceleration of the wedge. Here is your combo. Okay? You're only concerned with the acceleration of the wedge. Now look at this. When we did this equation here, see the one that's the one that's horizontal, see the one that's in this direction here. We did an equation in this direction here. Automatically the two parallel to the plane equations, you don't need them. So your combo for when you're looking for the acceleration of the wedge is this. You do the perpendicular to the plane, you do the second perpendicular to the plane, and finally you do the wedge itself. You only need 3 equations, not 5, to get those answers out. Is everybody happy enough with that? Now the perpendicular ones, see if you look at the equation of the wedge has r's and s's in it, yeah? And the only equation that will have r and s's in it are the ones that are perpendicular to the planes. Because r and s is perpendicular to the planes, they lie.